Hi everyone and welcome back. So today we're going to take a look at Unit 5. We're going to start a new unit today. This is going to be on data and statistics. So we're going to first begin with comparing populations. This is page 454 in the textbook. Okay, go ahead and put your name up at the top of your paper, please, along with the class hour and today's date. All right, let's take a look for today. All right, so for this one, we're going to compare two populations using the measures of center and variability. Compare two populations using measures of center and variability. And I'll refresh you on what those are here just a second. We've already, you guys have covered this before. All right, and then compare two populations when only one is symmetric. All right. Okay, so let me talk at you while you're writing. So the measures of center are the mean, median, and mode. Mean, median, and mode. All right, so you've talked about those in the past, so that shouldn't be that big of a deal. All right, so you pick mean, median, or mode to talk about, and then you need to pick something of a measure of variability. All right, so your measures of variability could include your interquartile range, your regular range. You can talk about if it's symmetric or not, if the mean absolute deviation is so much that you guys learned about last year. Okay, all those kinds of things. All right, so you have lots of different things you can pick from. There's a few that I prefer over others, but honestly, it doesn't really matter in the long run. Okay, so let's take a look at this one. All right, example 1. It says, Casey surveyed a group of students in her science class and in her math class. The double box plot shows the results for both classes. Compare their centers and variations. Write an inference you can draw about the two populations. All right, so let me remind you on how to read this. All right, so from one dot to another dot represents 1/4 of the data. Okay, so like this is, I can't draw it, but try and do one of those bracket things. There we go. Okay, so that's 1/4 of the data here. From here to here is also 1/4. And then from here over to here is 1/4. And then from here over to there is 1/4. All right, so as you can see, some fourths are very spread apart, whereas others are very close. Down here in the bottom, it's the same. Okay, from 0 to 15, that's a huge gap, but it really only represents 1/4 of the data. So that just means there wasn't a lot of numbers. Whereas from 15 to 20 represents 1/4, and 20 to 25 represents 1/4. Those are very close together, all right? And then from 25 to 30 is the same. So we're almost symmetrical except for that one in science class because you had people with 0 and then way down there at the lower section, okay? So what we're going to do is we're kind of basically just make a little table here. We're going to make two things. So we need to pick a measure of center to talk about and a measure of variability. Okay, and let's go ahead and write some of those things down. So what are my measures of center? Okay, we're going to put MOC here, measures of center. So my measures of center are the mean, the median, and the mode. Okay? And then let's go over here and let's talk about the measures of variability. The measures of variability are you have range, you have interquartile range, which is IQR or just IR for short, okay? Or you can talk about the if it's symmetrical or not. Okay, now some of these are good to pick every time, some of them aren't. All right, so like on the first one here, we all know how to find the mean, which is add up all the numbers and divide by how many there are. Well, the problem is, though, we have a box plot. We don't know how many numbers are here. We just have random dots all over the place. All right, so for this one, we either need to use the median or the mode. Okay, well, what does median mean? Okay, well, we know that mean means average. We've already talked about that this year. Okay, the mean means the middle. Oops, middle. I didn't spell it right. There we go. And then the mode is the one that occurs the most often. All right. Well, we can't really find the mean because we don't have any exact numbers. All we have is just the distribution of data. We can't find the mode because we don't know which number occurred the most, because that would be like for either a line plot or a bar graph, something like that, where we could see how tall things are going up and down, and we can't do that either. All right, so for this one, we're going to have to use the median. All right, so we're going to use the median as our measure of center, and we're going to compare it with math class and in science class. Okay, so how do we find the median on a box plot? Well, the median is the dot in the middle. All right, so this is the low extreme. This is the first quartile. That's the median. This is the third quartile because the median is actually the second quartile as well. And then up here we call this the high. All right, well, spelled low wrong. There we go. Oops. Okay, low. So, all right, so let's take a look at the medians. So the median for math was 10. In science class, it was 20. All right. Now we need to pick a measure of variability. So we can talk about the range, which is the high minus the low. We can talk about the interquartile range, which is Q3 minus Q1. Or you can talk about symmetry, which is, are they equal or equal spread? I guess is the easiest way to say it, equal spread. Okay, so let's take a look at this. So which one do you think would be an easy one to talk about? I think the range would be a good one for this one, just because we have the high number and the low number, and it's very easy to see what those are. Okay, so let's use that. So we're going to talk about range. All right, so what was the range on this one? Well, we have 30 and we have 0. So 30 minus 0 would be 30. And then we also have, for science class, be 30 minus 0, so it's 30. Again. All right, now we just need to make a little sentence about this. All right, so you can say that the median for math is lower than science. You could say the median in science is higher than math, and then the range is equal. So you kind of have a different way to say it. It doesn't really matter. Just kind of pick something and talk about it. All right, so you're going to write 2 sentences, so one about each. So let's say that the median in math was lower than science. The median in math is lower than science. However, the ranges are the same. Okay, so you don't even have to do 2 full sentences. You can do it in one big long sentence like that. Okay, just make sure it's complete. Okay, tell me both parts. All right, don't give me sentence fragments now. Okay, give me a subject and a verb and all that stuff. All right, so the median in math is lower than science. However, the ranges are the same. All right, that's all you got to tell me. So pick something from each category, all right, and then talk about it. Okay, let's try the next one. All right, this one says, the double box plot shows the cost of MP3 players at 2 different stores. Compare the centers and variability of the 2 populations. Write an inference you can draw about the 2 populations. All right, so for this one, we have electronics world, and we have bargain basement. All right, so let's just do EW and then BB for short. All right, so from our list over there that we made up above, okay, you can still see it on your paper, you can't see it on the screen. Let's pick something. So what's a measure of center we can talk about? Do you want to talk about the mean, the median, or the mode? Well, the only one we can really talk about is the median. We don't know which number occurred the most, and we don't know what the average is. So we're going to have to talk about the median, all right? So we're going to talk about the median, and then let's go ahead and find those. So where is the median on electronics world? Well, it's the dot in the middle of the box, so that's 70. And then in bargain basement, the dot in the middle of the box is only 60. All right, now we need to pick a measure of variability. So last time we used range, and that's always easy to do, but let's pick a different one this time. Let's try the interquartile range. So the interquartile range, okay, IR, IQR, however you want to say it, is Q3 minus Q1. Well, here's Q1, and here's Q3. Q1 and Q3. So you should remember that from last year, okay? You guys learned how to read box plots last year, so you should remember that. All right, so let's do that one. So let's do the IR, so the interquartile range. All right, well, what would be the interquartile range for electronics world? Well, it's Q3 minus Q1, so that'd be 75 minus 65, so that's only a difference of 10. And then on this one, we have Q3 minus Q1 for bargain basement, which is 65 minus 55, which is also 10. All right, so we would have ended up with the same. All right, so you can kind of pick the same ones every time, but I do try to recommend that you at least change it up a little bit. Okay, like the last one I probably should have done a quartile range, and this one used the regular range because the ranges would have actually been different. All right, so try to pick something that changes it up just a little bit each time. Okay, so let's write a little sentence about this one. So we're going to say that the median was higher in electronics world. So the median is higher for electronics world. However, the interquartile range ranges, I guess, are equal. There we go. All right, so I need either one really good complex sentence, so a compound sentence, or with a conjunction in there, or you need to write out two separate ones. So you'd say, you could even be more specific. You could say literally that the median is 10, let's see, is this dollars, I guess, or points in money? Yeah, so you could say the median is $10 higher in electronics world. The interquartile range is equal. Okay, you can make it two short sentences, or you need to make it one long good sentence. All right, let's try the next one. Okay, example 2. It says the double dot plot below shows the daily high temperatures for 2 cities for 13 days. Compare the centers and variations of the two populations. Write an inference you can draw about the two populations. All right, so for this one, let me scroll down a little bit here. Oh, I already worked out for you. How nice. Okay, so to find the mean absolute deviation, notice we picked the mean and the mean absolute deviation. Okay, remember the mean absolute deviation is the average distance from the average. Okay, so what they did was, when they found the mean of 81, okay, they found how far away each of these numbers were. So for Springfield, so they took 81 minus 78, 81 minus 79, 81 minus 79, 81 minus 80, 81 minus 80, and so on. Okay, they took the difference of all of those, and then they averaged that number together. All right, so each one was approximately 1.4 away from the average. Okay, so that's how they found that, in case you forgot how to find those. All right, so I already apparently made these up for you, so we just need to talk about it. So let's take a look here. So we have Lake City, which had a higher mean. So let's say that Lake City has a higher mean temperature. Lake City has a higher mean temperature. Okay, and then I kind of skipped over this. To find the mean, so this means that 78 occurred once, 79 occurred twice, so you do 78 plus 79 plus 79 plus 80 plus 80 plus 81 plus 81 plus 81 and so on, and then you divide by how many dots you have. Okay, so if you forgot how to find the mean on a graph, that's what you do. All right, let's talk about the mean absolute deviation. So they're the same again, so we'll just say that. So the mean absolute deviation for both cities are exactly the same. The mean absolute deviations are exactly the same. All right, so again, you can do two separate sentences or you can do one massive compound sentence. I don't care which way you do it, okay? It really makes me no difference. All right, let's take a look then at the next one. Okay, and I didn't give you any little hints on this one. All right, so this one we're going to have to pick some stuff out. It says the double dot plot shows the number of new emails in each of Pedro's and Annika's inboxes for 16 days. Use the dot plots to compare the centers and variations of the two populations. Write an inference you can draw about the two populations. All right. So remember, when we're picking a mean or a measure of center, we can use the mean, the median, or the mode. All right. Well, we used mean last time, so let's try the mode this time because we can actually use it. So we'll have Pedro and we'll have Annika. All right, so for Pedro, we're going to do the, what did I just say? The mode. Okay, so we're going to do the mode. So what was Pedro's mode? He had 36 and 37, so there were actually two modes on this one. So 36 and 37. Okay, and then we have Annika. She only had one mode, which was 31. Okay, remember, mode means most often. All right. And then let's pick something else this time for variability. So we've done interquartile range, we've done range. I don't want to get into symmetry yet just because it doesn't make sense on this one. So let's just do the range again. All right, so let's do the range. So we take the high number minus the low number. So it looks like Pedro's highest number is 37 and his lowest is 32, so that would be a difference of 5. And then Annika would have 38 minus 30, so she would actually have 8. All right, so let's do some sentences here. So Pedro has 2 modes while Annika only has 1. Pedro has 2 modes while Annika only, has 1. And then we need to talk about the range. Let's jazz up. Let's say there's a difference of 3. So Annika's range is 3 emails. 3 emails higher. All right, so you can actually give me exact statistics if you want. Okay, you don't have to just say higher, lower, higher, lower, higher, lower. Okay, or same, whatever. You can actually tell me a difference in there. All right. All right. Go ahead and finish up on that one. All right, let's go ahead and turn the page if we haven't already done so, and let's take a look at the last 2 examples here. All right, so it says the double box plot shows the daily participants for 2 zipline companies for 1 month. Compare the centers and variations of the 2 populations. Which company has the greater number of daily participants? All right, so let's take a look here. All right, so for this one, we are going to look at whether we have, I've got it worked out for you. So we're going to look at the medians and the interquartile range again. Okay, and then there's also one that I want to show you here on the last one. Okay, so we're going to look at the median. So remember, that's the middle dot inside of the boxes. So that would be 70 and then 50. And the interquartile range is the outside of the box on the right side minus the left side of the box. So 80 minus 50, which would be 30, and then 60 minus 40, which is 20. All right, so let's go ahead and make a little sentence about these two. So let's kind of change up. Let's say there's a difference of 20 in the medians. All right, and then let's do the interquartile ranges, and let's just say that there's a difference of 10. There is a difference of 10 in the interquartile ranges. We'll just do IR for short, okay? Now, if you notice in this one, there's a little star on Treetop Tours over there between 120 and 130, so about 125. Okay, that's called an outlier, and an outlier is a number that's either too far from the top or too far from the bottom to actually count into the data to make it appear correctly, all right? So that's one that we just kind of throw out. It's kind of like whenever I grade tests at the beginning, so like our CFAs, whenever we're grading those, if someone's absent for the day, I can't actually count them yet, all right? So whenever I do the first count, it tells me how many people actually answered, so I take the number out of whoever got the most proficient on there, out of that number, not how many kids are actually enrolled in the class, because if I did, then it's going to throw the numbers off, because those people then would technically be counted as a 0. Well, they didn't actually make a 0, they just haven't taken it yet, all right? So if I tell the computer to count everyone, then it says, well, that person got a 0, so it's going to throw your data way down. It's going to say the median grade was like 50% or whatever, okay, when that's not true. All right, so sometimes we just don't count certain numbers because they're too far, and there's actually a little formula to count whether or not there is an outlier or not, and I don't know if they teach that in 6th grade or not, but I know we used to teach it, and we just don't have to teach it anymore. So, but there is a little formula that helps us determine whether a number actually is an outlier. Okay, the other thing I want to talk about is if something is symmetrical. There were 3 options I gave you at the very beginning for measures of center, which is mean, median, mode, and they gave you 3 measures of variation or variability to talk about, which is the range, the interquartile range, and then finally if something is symmetric. Okay, think about lines of symmetry that you guys learned back in elementary school. If something has a line of symmetry, that means we can fold it in half and it would lay against itself, right? If I took a square, I could fold a square in half several different ways, right? And it would match up exactly. Okay, whereas a rectangle, I can only fold it across, so like a hamburger fold, or I can do a hot dog fold, and that's all I can do, all right? Well, on this one, when you take a look at Zip Adventures, this is what we call a symmetrical graph, or dot plot, whatever you want to call it. Because if I took 50 and I folded that thing over exactly, it would match up perfectly, right? Okay, so your median, which is your middle, would be your line of symmetry. All right, so you can also use that. Okay, I don't introduce that one till the end because everyone always wants to use that one, which is fine. I understand it's easy, but really you need to try to mix it up a little bit. So don't always use symmetry as one of them. All right, so we'll go ahead and use that on the last one down here. Okay. So you have a double dot plot, and it shows Kareem's and Martin's race times for different 3-mile races. Compare the centers and variations of the 2 populations and which runner is more likely to run faster. Okay? So let's take a look. All right, so let's do the mode again because that's an easy one. Let's pick mode. And then let's do if it's symmetric or not. All right, so we're gonna have Kareem and Martin. All right, so it looks like the mode for Kareem would be 18, whereas Martin has 15 and 17. Okay, now if there's not a mode, then don't pick mode as one of your things. All right, don't say there's no mode. All right, and don't pick that because it just doesn't look right whenever you do that. Okay, and then symmetric. Okay, so is Kareem symmetric? Meaning, can you take that middle there and fold it over and match it up? And yes, it would actually lay flat. So this one is symmetric. And then if you look at Martin's, his is not symmetric. His is all over the place, right? Okay, so this would be not symmetric. All right, so then let's make a little statement about these. So we can say that Martin has 2 modes while Kareem has 1. Martin has 2 modes while Kareem has 1. And Kareem's is symmetrical, but Martin's is not. I'll just abbreviate there at the end. Okay. All right. Then down here at the bottom, I have a little reminder for you. Okay, so remember to pick one from, and then you need to pick either the mean, median, or mode to talk about, and then you need to pick one from either the range, the interquartile range, or if it's symmetric. Okay, I really don't care which ones you pick. I would prefer you try to change it up a little bit and don't just keep picking the same ones every single time. All right, because what happens is everyone gets to looking for just if it's symmetric or not, and then they don't even know what range and interquartile range means whenever they get to the CFA, all right, or on another quick check or whatever it is. So don't just keep picking it because it's there, all right, and try to jazz it up so that way you're kind of well-rounded and you know a little bit of everything, all right? Okay, thanks for watching. Give me a thumbs up and subscribe if you haven't, and I'll see you next time.